Good day, geometry. Got another video today. We'll get to start chapter 15. And you probably noticed that we skipped chapter 16. That was an important chapter, but you'll learn more about law of cosines and law of cosines in your later classes. So we'll just stick to geometry concepts. So starting today, we're going to look at section 15-1. I'm going to do it in two parts, and this is part one. We'll go all the way up until we get to the homework assignments. So we'll do section 15-1, the beginning part. Okay, so the essential question we need to answer is, how can you determine the measures of a central angle and the measures of an inscribed angle of a circle? Now again, we're dealing with circles, and well, there's two things we got to answer now. What is a central angle and what is an inscribed angle? So that's the very beginning part on page 779. You're more than welcome to work out the explore part. I am just going to go and talk through the definitions and use the two pictures on page 779. Once again, you're more than welcome to do this, do the explore on your own, but I'm not going to go over that. So if you look at what we're dealing with today, is we have two pictures of a circle and some line segments going through it, and that all deals with defining to us what is a central angle, what's an inscribed angle. So the first definition that you probably should know is a chord. A chord is nothing more than a line segment whose endpoints lie on the circle. So again, if you look at these two diagrams, we see that the line segment, or the segment AB, that is a chord. Also, you'll see BD is a chord. Over here in this other diagram, you'll see that AB is a chord, and also BD is a chord. Again, it goes back to the endpoints of the line segment lie on the circle. And you'll probably remember, if I have a line segment that goes through the center, again, that's your diameter. All right, the next one is the central angle. That one is, the reason I'm pointing that out is because you got to know what the central angle is. Once again, it's an angle that has a measure that is less than or equal to 180 degrees. And the key here is whose vertex lies at the center of a circle. So again, if you look at our diagram here, this is the center of our circle, and the central angle is, in this case, your vertex is at the center of the circle. So if you see here, the central angle of this diagram is ACD, and also over here ACD, and you'll notice that your C is your vertex. And I also identified it in the same way from geometry. We go in alphabetical order, AC being the middle value, that tells you the vertex D. So these are called the central angle, or you can think of it as the angle coming from the center. That's another way of doing it, because a lot of this is common sense. You guys will have no problem doing it. Now the other one is an inscribed angle. This is an angle whose vertex lies on the circle and whose sides contain chords of the circle. So again, you see here on this diagram, B is your vertex. It lies on the circle. So ABD is your inscribed angle, and also your ACD is also your inscribed angle. So in other words, think of it as the angle that's on the inside of your circle, where your vertex is on the radius, or on the circle itself. Now this is important. These three things are going to be very important. Okay, you'll see why as we go along. Okay, all right. So let's go to the next page. Down below, you're more than welcome to do this on your own. I did not do it. It uses you and your protractor, compass, whatever that thing is. So I'm not going to worry about that, okay? All right, turn to the next page. The next page is understanding what leads us up to finding, or leads us up to how you can determine the measures of central angles and the measures of inscribed angles. Again, we got this down pat. Now, how do we measure that? So in order for us to do that, we've got to understand two things. We've got to understand what an arc is and what is an arc measure. So now the definition I have here in blue, an arc is a continuous portion of a circle consisting of 2 points, which are called the end points of the arc, and all the points on the circle between them. All right, what does that mean? Well, here they have a book. Here in the book, they have a table. The first one they're talking about is a minor arc. That is an arc whose points are on or in the interior of a corresponding central angle. So in other words, if you stop and look at it, to measure of it, okay, an arc whose points are on or in the interior of a corresponding central angle. So in other words, the minor arc, just to give you guys an idea, that's this guy right here. That is called the minor arc. Now that does have some significance. I don't know, we'll get to this in geometry, but that's called the arc length, but we're not going to really worry about it. So what we're going to do is how to find the measure of the arc length, okay? The measure of the minor arc is equal to the measure of the central angle. So in other words, if I want to find the measure of AB, that is going to be the measure of this angle, this central angle, ACB. So the measure of the arc in this situation is really just the angle of ACB. That's called the minor arc. Now the major arc is an arc whose points are on or in the exterior of the corresponding central angle. So in other words, in this case, it's if AB is your minor arc, then outside of the central angle, that's your major arc. That's ADB. And the measure of the major arc is equal to 360 degrees, because that's the angle measure of an entire circle minus the measure of the central angle. So if I want to find out, as this diagram shows, the measure of the arc, major arc of ADB, that means this arc right here, I just have to take that value and subtract it from the measure of the central angle. Okay, I'm showing you this so you guys, when you go and do some examples, it'll make a little more sense, okay? Now, a semicircle is an arc whose endpoints are the endpoints of a diameter, and it's very similar to the major arc. But you'll see right now, a semicircle is nothing more than half of a whole circle. So semi, like semi-sphere, semi-truck. Oh, never mind, that has nothing to do with geometry. So the measure of ADB is half of a circle, so that means the measure of a semicircle is 180 degrees. So there's your understanding of arcs and arc measure. Now we're mostly going to focus on arc measures, and you'll see it as we go along, okay? Next page. Now, the next thing they want to talk about is adjacent arcs. Now, when you're talking about adjacent, we're talking side by side. So again, adjacent arcs are the arcs of the same circle that intersect at exactly 1 point, okay? Now, if you stop and look at it, we can see that the arc of DE and the arc of EF are adjacent. Now again, you don't see it here, but if we were to go and create central angles here, so if I see the angle DCE and the angle ECF, we will see that these are central angles. And at the same time, these two angles, the DCE and the ECF, they are connected to each other. So that means arc DE and arc EF, they are adjacent to each other. That's what they mean by adjacent arcs. They're right next door to each other. So we've learned quite a few terms right now. We did identify what a chord is, central angle, inscribed angle. We've also taken the time and look at what an arc is, how to find an arc measure. We've also looked at adjacent arcs. Now if we can put all that stuff together, well, we're getting into how to find the measure of arcs in a circle. Now, one rule we're going to run across is called the arc addition postulate. Now, again, it's really common sense, guys. You probably know that. So the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So again, if you look at this diagram right here, I have two adjacent arcs. Pretty much what it's saying is if I have the measure of arc AD and I have the measure of measure of arc DB, and I add that up, that will give us the measure of ADB. Common sense. Okay, very important. That's common sense. Now remember, this is measure. Again, this is going to be done in degrees. Okay? Anytime you see this statement right here, the M, you're measuring it in degrees. All right? Down below, example 1. Again, you can pause the video, copy that. A lot of these are common sense. I'm going to let you guys just look at that, study it, and then be able to apply it. All right, the next one, I have a your turn here. So, okay, here we go. If we have the measure of arc EF right here, and they're telling us that that's 45 degrees, okay, 45 degrees. I probably should use a different color. We see the arc of EF, that is a measure of 45 degrees. And we also see the measure of angle ACD. That's this angle right here. They say that's 56 degrees. We would like to find the measure of arc BD. That's this arc right here. Using the appropriate theorems and the postulates, they also tell us in here that AE is a line, BF is a line, and DC is a line, and they also intersect at point C. So what we got to do is just pick this apart, use our appropriate theorems or postulates, stuff that we've used from previous sections or mostly in this section. So if the measure of arc AF is 45, then the measure of ECF will also be 45 degrees. Now to see that, see, EF is 45, so that means ECF has got to also be 45 degrees. So if the measure of ECF is 45 degrees, then the measure of ACB, that's this angle right here, ACB, has also got to be 45 degrees, all because of the vertical addition theorem. I messed that up. Vertical, I'll get back to you on that. What page is that on? Page 782. The vertical angles theorem. Okay, we remember that from a previous section. Okay, vertical angles theorem. All right, let's move on. Okay, the reason it's a vertical, look at this. If you see this angle, this line right here, that's 180 degrees. So if this and this go through the same lines, okay, we can apply that rule, which is the vertical angles theorem. Now, keeping going. Now, if the measure of ACB is 45 degrees, then the measure of ACD has got to be 56 degrees. All right, so if you look at it, the measure of ACB is 56 degrees. That means the measure of ACD, we already know, is 56 degrees because they gave it to us. Then the measure of AB will be 45 degrees, which is, again, let's see, that's this one right here. We found that earlier, okay? And the measure of ABD is 56 degrees. So if we go back and say, well, if I want to find the measure of ABD, I just have to add together the measure of arc AB and the measure of arc BD, and that will help us find the measure of BD, which becomes 11 degrees. Or we could have done a little bit of subtraction. We could have gone 56 minus 45. All right. Now let's go to the bottom part, okay? The next part is, how do you use the inscribed angle theorem? All right, we've already covered that. Once again, if we have an intercepted arc, consists of endpoints that lie on the side of an inscribed angle and all the points of the circle between them. Well, here's what it means. If I have here, once again, this, if you go back to your notes, ADB is your inscribed angle, okay? ADB is your inscribed angle. This angle is equal to half the measure of its intercepted arc. Now, what does that mean? So again, an intercepted arc consists of the endpoints that lie on the sides of the inscribed angle and all the points of the circle between them. So in other words, if we go back and look at this portion right here, that's your central angle. ACB is your central angle. ADB is your inscribed angle. And what it's telling us is that if we have the measure of ADB, it will also be equivalent to 1/2 the measure of AB. That's what it's telling you. So this is a good rule to hang on to. It's called the inscribed angle theorem. Hang on to that rule. Write it down somewhere. Again, once again, you could put it in your HD&Cs, but I think highlighting it in your book will be enough. All right, now here they do 2 examples. Let me go through letter B. We want to determine the measure of arc WX. So I want to figure out what this what the measure of WX is. Well, we already know it's going to be 9 degrees. Well, we don't know yet. It's going to be 9 degrees. The measure of XZ, the measure of WX, the measure of YX, the measure of XWZ, and WX and Z, using the appropriate theorems and postulates. All right, so by the inscribed angle theorem, we know that the measure of WZX is going to equal 1/2 the measure of XW. Here's your central angle of 9 degrees, central angle of 9 degrees. Let's back that up. That's your inscribed angle of 9 degrees, and we want to figure out what this, so it's going to be 1/2 that. So we know, so the measure of WX will be 2 times that. Okay, going back again. Here is your inscribed angle, and we know this arc right here is going to be 1/2 the inscribed angle. So if we can figure out, in this case, if we want to find double X, we just have to double the inscribed angle. So we get 18. Then you're going to notice that the arc WXZ is a semicircle. Okay, WX and Z, this is a, I'll make mess up, is a semicircle. In other words, this arc right here, WXZ, that's the arc, the measure of that arc. It's a semicircle, so it's going to measure 180 degrees. Then by the arc addition postulate, we know the arc of WXZ will have to equal the measure of WX plus the measure of XZ. So we know that semicircle subtracting from this arc length of WX is 18 degrees. That means XZ has got to be 162 degrees. Then by the inscribed angle theorem, we know that the measure of XWZ is going to equal 1/2 of that, so that you can go further. So the measure of XYZ is going to be XWZ will be 81 degrees. And we need to note that the arc WYZ is a semicircle, so WYZ is going to be 180 degrees. And by the inscribed angle theorem, we know now that that is going to be 90 degrees. Now again, this one takes a little bit of practice. Again, I think you guys can handle it. Just go through it real slow. Some of this takes common sense and you're going to have no problem. Let's do one more. Let's say we have the year turn. Here is our diagram. And it's telling us if the measure of EDF is 15 degrees, I showed it here. Determine the measure of A, B, E using the appropriate theorems. All right, now these get a little bit tricky, okay? You're not going to have any problems doing it. Now since EDF, okay, since EDF and EBF intercept on the same arc, they will have the same measure. Okay, so we already know now that this angle right here will also be 15 degrees. So by the inscribed angle theorem, the measure of ABF, so ABF has got to equal 1/2 the measure of the arc AF. Now they already gave us the arc of AF to be 44 degrees, so half of that is 22. So by the addition angle postulate, the measure of ABE has got to be the measure of ABF, which we know is 45 degrees, and the measure of EBF. That's this measure. And we already know that this measure is 15 degrees. So by the angle addition postulate, we know that the measure of ABE has got to be 37 degrees. Now these are a little bit different than what we've been doing. Okay, you just gotta go a little slower. Remember all your rules. And I have one more rule to go over. And this one is called the inscribed angle of a diameter theorem. So if we have the endpoints of a diameter lie on an inscribed angle, so in other words, if we have endpoints of the diameter, that's here and here, lie in an inscribed angle, there's your inscribed angle, if and only if the inscribed angle is a right angle. Pretty much it's just telling you that if I have a diameter and the endpoints of the diameter, and if it connects to another endpoint of the central angle connects to another point on the circle, it's going to be a right angle. Okay, just a little inscribed angle of a diameter. This is the common sense rule. So that is part one. So I want you to go back, look at all the different examples I muddled through. Go back and look at all the rules and theorems and definitions that we've gone over. And we're going to apply that stuff to examples in your homework, okay? So this is part 1 of 15-1. How can you determine the measures of the central angles? Once again, the measure of a central angle is this is the central angle, measure of a central angle, and how to measure the inscribed angle, just using the rules that we just gone over. All right, that's section 15-1. Thanks, guys. Catch you later.